Think about organizing songs on a playlist on your phone. You start with a fixed number of slots, similar to a CD with limited tracks. This is similar to how arrays work in Java. They have a fixed size. Once filled, you're stuck unless you create a new, larger array and copy everything over. But what if your playlist could automatically grow as you add songs without worrying about running out of space? Even better, what if you could easily remove or reorder songs without leaving gaps or manually shuffling? In this video, you'll learn how Java collections make it possible to manage data dynamically. Collections allow you to grow, shrink, and rearrange your data structures effortlessly. There are 3 primary types of collections: list, map, and set. The basic difference between a collection and an array is that a collection does not allow the storing of a primitive type, but only an object. Primitive types must be stored in appropriate wrapper class types, like integer for an int. In fact, primitive types are automatically wrapped in wrapper classes when we add them to a collection. First, let's explore lists. A list is a sequence of objects that can grow and shrink automatically, making it flexible for various programming needs. Within the world of lists, you have several options to choose from. First up, array lists. They're like arrays, but with a twist. Array lists come with built-in methods that make managing your data easier. Then there are stacks. Stacks work on the last in, first out principle, or LIFO. You'll use methods like push, pop, and peek to interact with the stack. And finally, there are linked lists. Picture a chain with each item linked to the next. This structure allows for efficient insertion and removal of elements. Lists are ideal for managing ordered collections of elements. The second primary type of collection is the map. Maps are collections of key-value pairs, where each key is used to find its corresponding value or object. There are hash maps that convert keys into unordered hash values for fast lookups. Then, linked hash maps are like hash maps, but the objects are ordered by insertion. And finally, tree maps are naturally ordered. Maps are essential for efficiently organizing and retrieving data based on unique keys. They are invaluable for tasks that require quick lookups and maintaining precise associations between elements. The third type of collection is one with no duplicates and is called sets. For example, a hash set has unique key-value pairs with no duplicate elements. Like linked hash maps, a linked hash set contains unique insertion-ordered elements, which means that the order of the elements stays in the same order as they are inserted. And of course, tree sets are naturally ordered. So, lists are great for managing ordered sequences of elements. Maps are perfect for storing and retrieving data using key-value pairs. And sets excel at ensuring that no duplicate elements are stored. To get a better idea of the benefits of collection types, let's examine the array list in more detail. Think of an array list or linked list, both of which support a collection of elements. Both allow a collection of object types with added convenience methods provided by a Java class. Array lists and linked lists both have an impressive collection of ready-to-use methods. Let's discuss a few of them, which are common to both the classes. The add method appends an object to the end of the list, with no risk of an array out-of-bounds exception. The size method tells you how many objects are in the array list or the linked list. The clear method removes all the objects in the array list or linked list. And remove deletes the first occurrence of an object from both an array list or a linked list. In this example, there's an array list with different types of objects added: a number, a string, and a date. The size method tells us the list contains 3 items. You can retrieve and cast objects, such as extracting the string hello from the list. The remove method allows us to delete specific items. And clear wipes the list entirely, leaving it empty. So far, this video has touched on what collections are good for, like storing different types of objects in a single list. But working with collections also comes with some well-known challenges. One disadvantage is that you are never sure what type of objects are inside an array list if the underlying array is of type object. That means you must cast items to their actual type when you get items from an array. This example illustrates that when you get an object from a collection, it returns an object of type object when we do not use generics. In the example, you can see that when you create the array list, you do not state what type of object will be stored in the array list, and so you have added an integer, a string, and a date object. So when you use get, it returns an object of the object class which has to be cast to the appropriate type. This is illustrated in the code which gets an object instance from an array list and then casts it to a string type. Casting an object to a string works when you know the type. But what if it's a different type, like an integer or a date? Casting these to a string will cause Java to throw a class cast exception. To solve this problem, Java introduced generics, which help ensure the correct type is known at runtime. Simply put, generics are a way to enforce type safety in your collections. With generics, you can specify the type of objects a collection can hold, making your code safer and easier to read. This array list can only hold objects of type string. The array list type is declared with the generics designator using angle brackets and the type string within the angle brackets. This limits the data type that can be handled by the array list to strings only. This means that all the methods of the array list that would have worked with the object type will now only work with the string type. This is because when it is created, you limit it with the open angle bracket string close angle bracket specifier. For example, here a generic array list of type string is declared and then the standard array list method is called. Notice that casting was not needed. If you run this as an application, the output would be green, the element at index 1. Overall, generics offer several advantages, especially when working with collections. They ensure that you only add the correct type of objects to a collection. This prevents runtime errors caused by type casting issues. And since the compiler knows the type of objects in the collection, there's no need for explicit casts when retrieving elements. Generics also allow you to write more reusable code. This is because a method that works with an array list using generics can work with any type, whether it's a list of integers, strings, or any other type of object. In this video, you learned how Java collections manage data dynamically and how generics ensure type safety. By specifying object types in collections, generics eliminate the need for typecasting, reduce errors, and make your code more reusable and clear. With collections and generics in your Java toolkit, you'll be better equipped to write safer, more efficient code.